Imagine waking up to a global alert no one ever wanted to see. A stadium-sized asteroid has just been confirmed on a direct course with Earth, and impact is only 2 weeks away. Small enough to slip through our detection systems, but big enough to erase an entire city. As it enters the atmosphere, the fireball would shine brighter than the sun. Traveling faster than 60 times the speed of sound, it would strike with the force of thousands of nuclear detonations, shockwaves flattening buildings and debris igniting the sky. Millions of lives changed in an instant. The unnerving truth is this scenario isn't hypothetical. We've already missed dangerous asteroids until the last possible moment, and some have passed closer than our satellites. So what do we actually do if a real killer is suddenly heading our way? For decades, scientists imagined asteroids as giant, solid metal boulders. But most are nothing like that. Many are fragile piles of rubble, loose stones, and dust held together by weak gravity. More cosmic gravel than cosmic mountains. And that changes everything. Because if an asteroid isn't a solid rock, it might not need to be pushed. It might be something we can break. Traditional ideas sound clever but need years of preparation. Painting an asteroid so sunlight nudges it aside. Attaching thrusters to steer it. Blasting it with lasers. All too slow when the clock is already screaming down from 14 days. So researchers have begun testing a far simpler option: hyperdense kinetic penetrators. Imagine a tungsten spear, 2 meters long, harder than rock, drifting silently in space. We don't fire it at the asteroid. We let the asteroid fire itself at the spear. At closing speeds of tens of thousands of kilometers per hour, the impact releases more energy than entire buildings full of explosives. Rock vaporizes. Metal liquefies. The penetrator carves straight through the asteroid's interior, fracturing it from within. One strike injures it. Several can shatter it. What should have been a single catastrophic city killer becomes a dispersed cloud of debris that Earth's atmosphere can swallow harmlessly. But there's a catch. We can't do this when the asteroid is already close. If the fragments arrive all at once, the combined shockwaves would still devastate the surface. So we need to intercept it far away, about 2 million kilometers out, roughly 4 times the distance of the Moon. That means launching within days of the discovery, racing across space, and positioning a single tungsten penetrator in the perfect spot. If everything goes right, the asteroid tears itself apart on impact, and Earth is showered not with destruction, but with a harmless flicker of cosmic sparks. For smaller asteroids, this could genuinely save us. But what if the threat isn't small? What if the incoming object is a true planet killer, a mountain of ice and rock carrying the energy of hundreds of thousands of nuclear warheads? Breaking it apart isn't enough. Its fragments would still be enormous and deadly. We would need to destroy or divert it when it is still millions of kilometers away, long before it becomes an Earth-ending bullet. And that requires something humanity doesn't currently have: constant sky monitoring, ready-to-launch interceptors, and technology prepared before the danger even exists. Because once a planet killer is spotted, there may be no time to build what we need. No second chances. No do-overs. The good news is that we already possess the knowledge and engineering to build these defenses today. We just need the will to prepare them. The universe is ancient, unpredictable, and full of wandering giants. And sooner or later, one of them will come our way. When that day arrives, our survival won't depend on luck, but on how seriously we take the threat right now. If you enjoyed this little brush with cosmic doom, feel free to subscribe. It helps the channel, and honestly, it reassures me that at least someone will be around to hear the next terrifying space update. Until then, keep looking up, preferably not because something's falling on us,